We're going to go over the last method of solving systems today, and that is called solving using elimination. So if you think about what eliminate means, it means to get rid of, right? So what we want to do is we basically want to eliminate one of the variables. And sometimes their equations are already nice and easily set up to do so, and other times we actually have to multiply when necessary. So it all depends on the situation, okay? So how do we eliminate one of the variables? We're going to eliminate by basically making them add up to 0. Right? And that's what we mean by canceling out, right? Like an inverse. So if we take a look at the first example, let me show you what I mean by that elimination. So if you look at the two equations, negative 2x plus 3y equals 4, and 2x minus y equals negative 8, you could go ahead and do your substitution, but what I see here is something pretty neat. I see this negative 2x and 2x, and what I'm thinking about here is, hey, wait, if I could add them together, don't they add up to 0? And if they add up to 0, doesn't that get rid of the x's? And that's exactly what we want to do. So I'm just going to rewrite the problem and then complete that elimination. So what we basically want to do is we want to add all the columns together. So you want to make sure everything is lined up with like terms, including the equal sign, including your constants. And then we just want to add downward. So I'm going to add the x's, I'm going to add the y's, and then I'm going to add the numbers. Right? So you can see how everything is nice and lined up with those like terms. And remember, what we needed to happen was one of these has to add up to 0. So those x's actually cancel each other out. So that's a 0x left over. Right? Then I can continue adding. 3y minus y gives me a positive 2y. 4 minus 8 gives me negative 4. And what this does now is this gives me an equation that we know how to solve from chapter 1. And that's what gives me y. And that was just so much faster for me personally than to substitute, right? To solve for y and substitute. Once we have our y value, we can go back and plug it in for x. It doesn't matter which equation you use. I'm just going to go ahead and use the top one. And then I'm going to go ahead and plug in to negative 2 for y. Right? And then I'm going to get negative 2x minus 6 equals 4, and then again just your inverse operations to get what x equals, right? And once again, always for us right now, write your solution as an ordered pair. Okay? Feel free to check if you want to double check if your work is correct. But again, what we need to do is just basically eliminate. Okay? So if we take a look at B, you might see this and be like, nothing can, cancel out right away. So maybe I want to go to substitution. In this case, I wouldn't recommend that substitution because a lot of us don't like to work with fractions, and you're going to end up with fractions if you solve for x or y. So what I would recommend you do is let's manipulate that top equation so I can actually get rid of the bottom, either x or y in the bottom there. So it's up to you if you want to get rid of x or y. I always go with whatever I can see most easily. And for me, that's going to be the x's. And right now, you might say, well, Ms. Huang, you can't make them 0. You're right. But what could I do to that 3x to make it the opposite of negative 6? Well, what if we took this 3x and made it into a positive 6x? Doesn't 6x and negative 6x cancel each other out? Right? Now the question is, well, how do I make that a 6x? Well, what if I just did 2 times 3x? Isn't that 6x? So I'm just going to take that entire equation, because that 3x is part of this entire equation, and multiply it by 2. So let me show you what I mean. So I'm going to rewrite my problem. And what I want to do is I want to take that top equation and multiply everything there by 2, because I don't want to change the actual equation itself, but I want to rearrange it so that I get a positive 6x on top. So now you're going to see I get 6x plus 4y equals negative 4 on top. And then a negative 6x minus 5y equals 2, which is the same as the original problem. And the x's cancel out beautifully, right? And that's what we want. So we can always multiply to change the coefficients of x and y to make it the opposite, right? To make them eliminate. So I'm going to go ahead and add down just to finish off my work. Dividing by negative 1, y is going to be 2. And then, doesn't matter which equation you use, I'm just going to go ahead and use the top one to solve for x. And then as always, write your solution as an ordered pair. Here it's negative 2, 2. And if you want to check, feel free to go back and plug it in and see that it works for both equations, okay? So you can have problems that are already set up nice and easily for elimination. You can multiply to get that elimination to work, and you don't always have to multiply once, you can also multiply twice. So what I want to bring your attention to right now is if you flip over your page to number 3 on the U try, let's get started on this together, and then you can go through and finish off 1, 2, and 3. So if you look at number 3, you might be seeing, okay, it's 4x and 5x, negative 3y and negative 2y. Nothing's really going to come nice and easy, right? I can't just eliminate the x's or eliminate the y's right now because they're not opposite numbers. And I can't just multiply 4 by 2 or, negative 2 on the bottom by 7 to cancel out the y's or the x's. So what I'm going to do is I'm actually going to multiply both equations by something. And here's where, again, it's up to you and what you want to choose. Do you want to get rid of the x's or the y's? It doesn't matter because it's going to lead you to the same answer. Here, I'm going to go ahead and pick the y's just because I want to deal with the smaller numbers. So I'm just going to focus on this for a moment and think, well, what's the smallest value that would be the same here, right? That I could multiply 3 and 2 by to get, some number to cancel them out. And hopefully you guys are thinking 6. You can always go the opposite. And what I mean by opposite is like, see how the bottom number is 2? Multiply the top by the bottom number, and multiply the bottom by the top number, and you will get that number that they have in common, which is 6. Sometimes the number doesn't have to be, the numbers multiplied together. You can just make a little multiplication chart for yourself. But anyway, I don't want to confuse you with all my talk. So I'm going to go ahead and just do that. So I'm going to think I want to get a positive 6y and a negative 6y. And I'm doing that by multiplying by 3 and 2. So I'm going to rewrite my problem. And like I said earlier, I can multiply both the top and the bottom. There's no reason why I have to limit myself to just one. And I decided arbitrarily I wanted the positive on top, so I multiply the top number by negative 2 to make it out a positive 6. And then the bottom by a positive 3 to keep that a negative 6. And then we'll see our transformed equations. Negative 8x plus 6y equals negative 16. And 15x minus 6y equals negative 33. And those y's now cancel out perfectly. Okay? So I'm going to stop right here, let you guys finish it off. Please make sure you are checking your work, right? And then we'll check all the answers together in a moment, and I'll take questions when we come back to class. All right, let's check your work. So again, doesn't matter which one you eliminated, but you should get the same final answer I did. So 1, 2 for number 1, 6, negative 6 for number 2, and then negative 7, negative 12 for number 3. So feel free to copy down my work. You can always scroll back and pause if you need to. But please again come back to class with questions. We'll finish with that word problem and practice. Thanks for listening.